Now that I begin recording, basically, welcome to the review session that begins before the final session of the class. So tomorrow and Thursday we'll cover virtual memory. Is one of the topics I hold really dear to me because part of it is on my thesis. I designed a virtual memory system for GPU. Actually, in fact, I was one of the very first people who proposed some of the designs for the GPU specifically. Um, I also is Thursday the holiday? I think so, but it opens up as a class on Sky because usually if it's a holiday where I don't have to teach, it won't be up on Sky, right? So that's my impression. That I thought there's a class on Thursday. So I guess we'll have a class on Thursday, but if you're on a holiday, I'll do the recording. Do we have class next week? I don't. Next week is final, right? So, uh, we won't have class next week, and we will basically have fun working on an exam. I think this is last week. Wait, I think you're supposed to know this. Am I confused? Like, just want to double check. This is the last week of class, right? And next class, then next week is the final week. Just to double check too, because I'm a part-time lecturer, so I just want to double check that I'm on the same page here on the schedule. Okay, perfect, awesome. All right, sorry, that made me going into the panic mode a little bit. Uh, so we'll begin today by a quick recap, right? Because we talked about multiple things in this class. We talked about how to use Linux. We talked about how to use C. These two topics will not be on the final exam, all right? Will not be on the final exam. Then we talk about assembly. And we talk about data representation, how do we represent numbers, what's the cache, and then we will talk about the virtual memory. These are intro to computer organization. Basically, you are trying to get to know how the computer works. Um, Now, I want to talk about from this knowledge, right? What are the possible direction in computer science where you can explore, right? Because this is another important thing. There's so many different topics in computer science that you can explore outside of just develop a code and be a software engineer. You can work on how to build a system. You can be like me and work on how to build a computer, change the hardware. You can be like someone who design how to maintain a data center. You can be someone who look at really high performance server and look at how do you solve the next complex scientific problem and work on high performance computing. There's so many things that you can do. So anything that come after the slides now, right, will first of all will not be on exam, and these are my opinions. So what's next, right? Feel free to ask me anything because this is one of the makeup session where I want you to look ahead rather than look back and review the material. Right? I want you to look ahead and think about uh, avenues where you can work on, right? So these are some of the sample topics that involve more hardware, things like computer system, building Linux, right? I told you about one of my friends who built the kernel when he was 12 years old. I mean, you don't have to go that far, right? But you can be someone who built another distribution of Linux because you found that Ubuntu is not good enough. You can also work on certain features in Ubuntu, right? And make it faster or make it more reliable or allow certain features that would work with new hardware or even a new framework, right? You can also work in distributed system where you have multiple computers connected to each other, right? And together they perform computation and allow you to get a faster and faster program running and make sure that they are reliable, right? So let me ask you this quick question. What would happen if computer not no longer becomes reliable? I throw in something, I get some some inaccuracy in my results. Yeah, by the way, sorry, it's only 5 of you guys, so all the question asking would probably like requires more time until someone respond. All right, no one respond. So basically, you want to make sure that the data you're sending around is reliable, right? You can also build the cloud computing environment, right, where you can build the actual cloud, not just be the user of it. You can also build the IoT system where it allows multiple devices to connect it, and not just connect it. Connecting to internet is easy and dumb. Let me be frank here. Like a lot of people especially here in Thailand, think of IoT as like, oh, I have something and I connect to the internet. That's not IoT. That's like embedded system which I have a device connected to the internet, and that's a really stupid, to be honest, way to look at the more like a uh, interesting work in IoT, which is how do I make it scale? How do I connect multiple devices together where the number of devices can go to like 10,000, right? How do I make sure they are reliable? How can I make sure that whatever I send will not be intercept and being hacked, to be honest, right? And how do I do that cheaply? How do I coordinate between cluster of devices connected so that it can work together in one single system? These are a lot of system building work. Right? You can look at computer network, computer security, and sorry about the like capital letter. I should use the lowercase n and lowercase s in a computer network and computer system. My bad. You can also look at compiler, right? Many of you here are taking fun part, right? Funhara kind of like is a gateway to parts of the compiler world. Where you look at the language, where you look at the construct behind what goes into the language, right? And also the compiler optimization, how to make sure that your compile program is fast, right? Database system, how do I maintain a large database, or how do I maintain a distributed database, or how do I maintain even a small database so that it's quick and cheap to implement, right? Or even things like a storage system. How many people here use Dropbox or Google Drive or something? How many people here actually still uh, well, we all use it, right? So how do you imagine like how they actually synchronize all the data? So that's only one single element of the topics, right? But also even storing file, right? That's in your hard drive or SSD. How do they access them so quickly? When you double click on the file, it seems to be able to find the location that block on the SSD and give you the file. Right? These are not free. These are not also not magic. These are all coding. There's different elements of things you have to code to maintain the location of your data. Uh, Parallel programming, directly applicable to Funhar. If you use Rust, you've been seeing sample a really good parallel program. Embedded system and computer architecture. Embedded system is basically if you want to program a microcontroller, things that go into your car, things that goes into all the devices around you, right? How do you do that? In fact, an embedded system required a lot of C knowledge, because you have to program in C in many cases for these microcontroller. Computer architecture, how to build hardware. So let's go to some of these topics that I know and I'm relatively familiar with, right? Computer systems, if you're interested, take the OS track, right? How to build functioning operating systems. If you somehow hate yourself and like kernel hacking, I'm joking, but it's actually some Kernel hacking is a lot of grunt work, right? Imagine you work on a code, and the only way you can test is to turn the computer on and see if it runs. Imagine that. You don't have GDB, you don't have printf, you have to write your own printf. And if your own version of printf doesn't spit out the text on the screen, how are you going to debug that, right? Yeah, so to be honest, the first time I tried this for the embedded version of the OS, like it's basically the operating system that go into the microcontroller, it's painful. Because I boot it up, and the only thing I can see are lights, and that's all, and nothing on the screen, right? So there's several tricks that you can try to do, but it's mostly about like knowing the system through and through, and make sure that you have every single order of things correctly. But it also can be fun and challenging, right? How do you manage all the running processes and tasks, right? So let's say I give you an example. Like I was, let's say you're queuing up on, it's gonna be an old game, like Dota 2, right? Games in my generation. So let's say I play a lot of Dota 2. And one thing in Dota 2 is when I want to play, I need to match up, right, with the other 9 people so that we can start a game because the game consists of 10 people, right? So while I'm waiting, what can I do? I can open up Chrome, put YouTube on a different monitor, right, and watch YouTube. So let me ask you this: which tasks are more important to me? Dota 2, whatever is on YouTube that I'm just basically watching on the side while I'm waiting out for the game to start. Which one is more important? I guess to me, which is the user. Uh, most of the case, right? Dota 2, because if you two pause for like 1 second, it's okay. But if the queue is up and it's my turn to hit accept so that we can play the game, I did not see that. I need to re-queue again and it would take a lot more time, right? So Dota 2 gets more important. In this case, how does the OS know? Right? Imagine this. It's just a thread, right? It's just a process. It's just another application with some ID, some random ID. But how does the OS know that, okay, this application is more important than the other? Also, how does it know that sometimes application has promotion into like, hey, I'm now important. You're now less important. How does it manage that? How does it actually balance out what CPU would handle what? This can be called the things like load balancing, right? Making sure all of your like 6 CPU are working on something that has a similar length of time you have to run, so that it's finished roughly at the same time. Like basically, it so that it actually reach certain goal that improve user experience, right? Because that's what you care about, whether I have a better experience using Windows or Linux or Mac, right? How many people use Windows and Mac before? Like both of them and Linux, or like a pair of those. How many people used to own a Windows system and now convert to Mac? Oh, how about Windows and Ubuntu? Which one do you like more? Which one is more friendly toward your own experience? You still use Windows more, and can I ask what reason is that? I also use Windows more, although I hate it. Any specific reason that you use Windows more? Convenience for sure. How many of you play games? Yes, a lot of games, right? I use Windows because no one ported it to Unix. So not to Unix, but to Linux, right? So I was like, okay, fine. If I want to play games, I would need at least one machine that is a PC that run Windows. Um, and that's a fact, right? But how about some improvement? Imagine a world where there's no Windows subsystem for Linux, which is I guess my undergraduate world. I don't have WSL, right? I would use PuTTY all the time, but now you have WSL. It's much more convenient. It's actually a lot of fancy system trick, right, that you have to do to make sure that you can map um, all this command, including the path variable. How many of you know that Windows also has its own path variable, the path variable that we learned in lecture 1, I guess lecture 2. Do you know that Windows also has its own path variable? And like imagine now you have to maintain a Linux version of path variable in WSL. But Windows subsystem for Linux run on Windows itself, right? Oh, you did set up for some languages, yes. Right. So if you want to install like C and C++, you need to set it up so it knows where's their GCC compiler, right? But you run WSL and somehow you have the two path variable, right? So how do you manage them? So that's another really important design elements of computer system, right? Things like how to manage data mapping, how to map different data to different memory. How many people use RAID or heard of it? And I love using wait, no, that's a game. I think I'm young enough relative to the other professors to know a lot of games. And also do play a lot of games. I wish I have a little bit more time. These days I don't get to play games except for on my mobile phone. Right? Occasionally when I'm trying to put my daughter to sleep, I would sneak in playing games. Not sure if that's a good thing for a parent to do, but yeah, that's where I am. Ray, anyone heard about this word before? How many of you built your own desktop? Anyone here have built your own desktop? So if you've done before, right, RAID allows you to basically, let's say you buy 2 hard drive, right? Is hard drive slow or fast? If I need to open a file on a hard drive, it's slow, right? So if you use something like RAID 0, it allows you to basically, let's say I have file A that I want to access, right? File A. A portion of file A will be here. I guess A1 is a part of file A, and the other part of file A will be striped here, file A, again, A2. And then RAID 0 allow you to use both hard drive to stream out file A, but both of them would work together so that the speed ideally, so what should be my speed up? Ideally. So now I have 2 hard drives working together to stream out the same file. What should be the speed up? It like the ideal speed, yes, right? 2x, right? Ideal. In reality, it might not reach 2x, but it's a lot faster, right? Now, these are system solutions to making things faster. There's also like things like distributed file system, or even things like RAID 1. So if you use RAID 1, these are not for speed, but these are for uh, reliability. How many people have hard drives that go bad on you? Basically, somehow your hard drive just broke and you lose all the data. Anyone ever had that happen? All right, how do you feel? Sorry if that's a PTSD for you. So RAID 1 would have this for you, hard drive, right? So you have two exact same hard drive. This is copy A, copy B. They have the same copy. Oh, perfect timing. Oh, okay, that's a perfect timing. Basically, you have two copy of the same file on both hard drives. So let's say this one fail, you still have the other one. So RAID 1 would manage this for you. If one of them fail, it would tell you that one of them failed. Please switch it out, buy a new hard drive, plug it in, and now you have a functioning disk again. You don't lose the file, right? And this RAID technology comes with multiple versions. You have RAID 0, RAID 1, RAID 4, RAID 5. In order for you to basically figure out what to do to manage all these data, right? And this is a really, really old technology, right? And I had a chance to actually meet with the professor who came up with this technology too. He was a professor at CMU. He now moved to Toronto, and it's still used in data center nowadays. It's like one of the most important technology in storage systems, right? But whatever you're doing here in this class is kind of like a fundamental knowledge that you can build on top to keep looking into this direction. And finally, hopefully in the future, in the next 5 or 10 years, you can come up with these awesome solutions as well, right? Or things like how to manage all the shared libraries, or how to build a functioning cloud infrastructure, right? How to handle data communication, how to synchronize the data. These also include things like distributed system and IoT, how to build a HPC cluster, like so that you can have a really fast computer, right? And so that your computer get ranked at like the list of the fastest computer on the in the world, right? Or how to ensure that the computer would eventually see the same set of data, right? Something like, let's say you have an Instagram account, right? And your friends update their Instagram. You need to, like, as a owner of Instagram, which is Meta, right? The company. Meta have to make sure that eventually you see your friends update. And it had to be in the same sequence. So let's say I have a profile picture of me, and then I switch to my cat, and then I switch back to myself. You should see that same order. Me, then to my cat, then to myself. Not me to my other picture, and then my cat, right? You should see the same order. Generally, this is what a lot of people call, like, it's not even back end. It's not back end from the point of the web development. This is like back end when you think about the computing stack, right? You build the system, you build the things that goes into the system, right? Not just using it, but now you built it. The other thing is compiler. You've been using one for a long time. GCC or Python, right? It's a tool. It's a program that translates your code into assembly. You can think about it this way. But the thing is, your program, GCC, also optimizes your code into an even faster assembly. Anyone try this? Dash O3 in GCC? Anyone know what Dash O3 do? It optimizes as much as possible. Basically, it's to allow you to enable every single optimization known to GCC. Right. So let me get you the list of these optimization. Why is it so hard to find like a GCC manual page? Okay, let's look at optimization level. Here. You see my screen? So you can do -01, for example. It will say, if I do -01, I'm gonna turn on all these options that I know that it would make your program faster. For example, delay branching is to delay the if else so that I can play with the hardware or the knowledge of my CPU, and I do certain tricks to utilize the CPU such that I don't have to figure out what's the result of the if else until later, because that can make your program faster. I can do -02. -02 basically apply all the -01 with all this additional optimization, right? And -02 have these additional optimization. I am not going to go into any of this detail on what they are, because to be honest, I don't know. Right? I know things like reorder functions. Basically, it allows you to reorder some of the function call, right, to make sure that it's more friendly toward hardware and it's hopefully faster. -03 would also apply everything in -02. On top of that, you add this, right? Things like split loop, pure loop interchange, loop unrolling, and jam, right? This allows you to hopefully apply optimization and hopefully your program run faster, right? But at the same time, GTD is a program. So if you compile a large program with -03, it might take a longer time to compile, right? You can also go with -00, and I go with the default. I don't do optimization, and then I reduce compilation time, right? So how long does it? Let me ask you this: how long does it take for you to compile your code for your assignments? Not long, right? Have you ever experienced a time when you ever have to compile something and you can go to lunch, come back, and it's about time it's finished? Imagine that. Imagine if that happened to you. Do you think it's possible? So I had some experience going to do internship, right, at multiple companies in the US, right? And that's the first time when I realized that, hey, compilation time can matter. Because sometimes it does take a long time to finish the compilation process, right? I've been seeing codes that take 1 hour to compile. If you do a make clean and have to compile from the beginning, it can take even longer than that, right? So these things can matter. These things can impact your programming experience, right? And if you do -03, that would make the compilation time even longer. People who do compiler also think about how to represent your program in a way that's easier to optimize code, right? Or what's the best method to map your program to certain hardware. Let's say you buy a new MacBook with the M1 chip, then the new problem is, well, I have program compile for x86. What do I do? Because they use ARM ISA, right? It's like I have a person who talk in Japanese talking to another person who talk English and they don't know the other languages. You're going to be the translator, and that can take a long time for them to communicate, right? Or like how to deal with loops, how to deal with data access. But these things are uh, uh, factors, I guess, that impacts performance. Side topic is things like programming language, the beginning part of your fun part, right? So hopefully you guys are having fun over there. Good luck with the exam tomorrow. I'm sure you do well, but still good luck with the exam, right? Things like embedded system is also really important too, because you sometimes you have to program low power device like Raspberry Pi or NVIDIA Jetson. NVIDIA Jetson is another small computer that you can buy, it has a small GPU in them and a really, really weak CPU, but it's enough to run the OS, right? And you can use it to run a lot of GPU workload on a small device. And generally, you need to now learn how to process a lot of I/O requests, input and outputs, because these things be connected to actual sensors that read things like temperature or things like the humidity and control a lot of other output devices like the thermostats. It reads the input from temperature and make sure it cuts the air conditioner because it's too cold, right? Things like that. It also can involve a lot of kernel hacking. It's similar to OS, so that your code is efficient and is timely, right? So assembly is also common in embedded systems because you want to pack your code to improve efficiency. Task scheduler also is important because you need to make sure that you manage a lot of compute tasks, like in a self-driving car, right? Imagine I have one program to try to figure out what's the object in front of me. I have another application that try to figure out if I need to drive to my destination, right? What should be the path? Should I go to this highway or a different highway? I can have another program to try to figure out where are the lanes, right? And where are the signs and what are on the signs, so I know exactly is what's the speed limit, is there a stop sign in front of me, right? And then I need to figure out what do I do based on all those output. Sometimes certain tasks are more important than others, right? What if I was not able to finish the task, let's say, what's the object in front of me in time? What could happen? What could happen if I screwed up scheduling and I was not able to finish the application that tried to figure out what's the object in front of me when I'm on a self-driving car? It basically means that someone can die, right? Let's say that object is a human. That human can die because the car will not be able to respond to the results because we haven't finished even computing that, right? Things like storage systems is about how to manage your file, how to manage the SSD, hard drive, or even cloud storage like Dropbox, Google Drive, right? Why is this important? This is one of the key reasons why your program gets slower, and it's also where you store all your data and all your programs. So some of the key issues are throughput, how many bytes that you can read or write per second, reliability, what if your disk crash, or what if you write too many times to the SSD and it dies, right? Or things like latency. If I want to access a file, how long does it take for me to access the file? So these are all the things that you can build on after you know how to write program in C, right? Parallel programming. Once you know caching, then you can take advantage of all the, I guess, first of all, multiple cores you have on a computer, including the GPU, how to generate parallel tasks, be aware of the cache, be aware of the hardware constraint, and deal with data synchronization, how to check, first of all, check the sequential bottleneck and reduce it, right? Uh, Example parallel programming languages and frameworks, something like Rust, OpenMP, CUDA, OpenCL, or Silk, right? If you're interested, definitely check with Ajahn Kanat. He's one of the world expert on parallel algorithm. You can also check with me. I am more on the hardware side of things, right? So now I'm going to switch gear a little bit. I'm going to talk about computer architecture, which is basically the area I actively work on, right? So anyone seen this before? This building? Anyone know what is this building? And I know it's only 4 of you. The Louvre, right? Awesome, thank you. So this is an architecture masterpiece, right, by one of the architects. So what's this? By the way, this is a hiking trip where Ajahn Kanat is actually, we were hiking with Ajahn Kanat too in a group. And it is actually close by Pittsburgh, where we got our PhD. And it's about 1.5 hour drive from there. The fall is called Cucumber Fall. It's not even big, right? It's actually like a smaller waterfall. but it's a pretty good like photography spot, right? So as you can see here, it's pretty easy to get it to look kind of nice, right? Let's say I have a lot of money, like I am a rich person. I say, hey, I want to build this is like a cool waterfall. I want to build a house on a waterfall, right? Let's say I have this. Anyone seen this before at all? Anyone heard of the architect called Frank Lloyd Wright? Oh, okay, you guys heard of him. So this is one of the UNESCO World Heritage Sites close to Pittsburgh. This is one of the only few like tourist attraction if you happen to get drunk and drop by Pittsburgh. Except for if you want to watch like American football, right, or watch hockey, we are actually also really known for having really good teams. Imagine the Liverpool of American football and ice hockey. We do have the teams like that, but this is another famous tourist attraction. It's a house on a waterfall. It's actually called Falling Water. It's designed by an architect called Frank Lloyd Wright. He also designed many other buildings in the US, right? Uh, and as you can see here, right, it's actually built on top of the waterfall, and it does hold itself for multiple years, like hundreds of years. And in there, if you take a tour, right, if you happen to be able to take a tour, the guy will tell you that okay, the architect want people to come outside to appreciate the nature, to actually watch the scenery, right? So the way he designed the house is like the common room will kind of get exposed to the nature. The bedroom will be smaller, so they would encourage people to come out. And there's also like guest room design in certain ways to make sure that it match with the whoever is paying him basically to build the house, right? So that's the architect. So how about computer architect? Basically, what we do is we design computer. We design computer. We don't design houses anymore. We're not an actual architect. We are the fake architect. We design what goes into your computer. Um, the thing is, if you know about how do you need to become an architect, you need to know things like you need to understand the basic of physics, right? You need to make sure that if you put things together in a house or in a big building, they would hold and they won't collapse, right? So that otherwise people die. So similar there, our field, I need to know some limited amount of the circuit knowledge so that I know if I put this and this and this together, it works the way I want them to. I also need to understand the hardware. No, my bad. I need to also understand the software, right? In a sense that if I want to build a computer chip, I need to know what will get run on the chip. Because otherwise, there's no way I can design a good hardware because I don't even know the user demand, right? So that's kind of like a rough uh, job of computer architect, what we do, right? And that's why you've been seeing newer and newer chip from AMD, Intel, Nvidia, and many other company like Qualcomm, Apple, right, that keep pushing out cooler and really fast CPU that gets smaller somehow and also use less power, right? We also do go green to some extent, right? We want to make sure we don't limit, we limit the power output that we require, not power input that we require to feed into this logic. Right? So these are the job of the computer architect. And that's it. Any questions so far before we go to the final exam review and like the format and everything? That's the end of my like I guess rah speech about why learning all this thing and going through all the pain of like the sigfox, the caching, and you will also look at virtual memory and you get confused and the assembly that you learn. So it's because it would enable you to be able to learn more advanced concepts that can help if you want to, I guess, work at Google, at Microsoft, or at Apple and Amazon, or those like top companies. Before we go through the final exam review, I'm gonna do a quick pause here. Let's do a 10 minutes break. In the meantime, I'm gonna check Discord and see if we have any questions from the chat. I'll come back and answer all those questions, and then I'll talk about the exam format and everything after we're back at 3:05. All right. Now let's talk about the final exam. By first going through the format. The same deal. We'll do Thursday release at 10 o'clock, and you have until Friday, so that's around 38 hours that you can work on the exam. It will be released on Thursday, July 21st. There'll be a live session between 2 to 4 p.m. for Q&A. I basically will be on WebEx, not even having my video up. And I'll respond to any questions you have. Any further exam related question, email or ping me on Discord. I should be notified now with the notification on the phone, right? But the response times depending on my work schedule as usual after 4 p.m. The study materials are things like in-class exercise, assignment 3, 4, and 5, right? And here are the topics for the final exam. Data representation, program representation, how do I represent a program, how does a program get represented in assembly and in binary. Data representation can be things like, I have a number, how is that represented in binary, and something that looks like a task question 4 of the midterm, but kind of targeting this representation. Things like assembly, how do I handle certain things? I can ask a question where you fill in the blank in a similar fashion as the in-class exercise. Those are fair game. The fact that programs and data are all in DRAM, the memory hierarchy, caching, and virtual memory will be guaranteed to be on your exam. I have a free questions always every single year. Next tomorrow we will learn what is a TLB. So one of the free questions will be, what is a TLB? All right. There's also a previous exam that I'll post. Basically, this will be posted. Will be posted tonight. You can ask the questions about the previous year exam on Thursday. We can go over just on Thursday. If you have any questions, a quick note. The exam I'm gonna post is not perfect in the sense that there's some typo in there. But I have to kind of double check what's the typo because I forgot. I'm so sorry about that. But if something doesn't make sense to you, you should ask. And I'm not gonna post the answer because I want you to work through it, and we can go over that on Thursday as well. Basically, we go over this on Thursday, and now is the time for Q&A for your assignment 4 and 5. You have a chance to take a look at that. So, do you mind if I switch over to Discord right now so that we can handle the Q&A? Is that okay?